Hello students, this is Mr. Yao. In the last lesson, we have learned to generate exponential graphs by plotting. Then of course, after we have seen the exponential graphs, now we are going to talk about the features of those exponential function graphs. Prior knowledge, exponential function graphs change fast without bound on one end and change slow going almost flat on the other end. That has been the wording we used to describe exponential graphs since the last unit. In the last unit, when we learned about features of functions, we have also learned about domain, range, and end behavior. So let's quickly review their definitions as well. Domain is all the possible x values, range is all the possible y values, and end behavior is how a graph acts or behaves on either side of the function. And the notation for end behavior for this year, we have been using as x approaches negative infinity or positive infinity, f of x approaches. So let me write that down to quickly remind you. As x approaches, it could be either negative infinity or infinity, f of x approaches. So let's have a look at two examples of things that we have learned in the previous unit. Domain for both graphs. Well, for exponential graph, since it's always from left all the way to the right, so domain is gonna be negative infinity to positive infinity. Doesn't matter the shape of the graph, it's negative infinity to positive infinity. As for range, if we look from bottom to top, you can see there's nothing over here on the bottom, there's nothing over here on the bottom, there's nothing until we hit 1. But since we have talked about on this end, the graph is going almost flat, it's not exactly hitting 1. So when you squish, you don't get a point on 1, but right about 1, you're getting some points. So you're getting all of these. So it's from 1 to infinity. To not include 1, we're going to use parentheses. On the second one, well, nothing below, nothing below. So the first point we're getting is -4, but just above that. And then we have everything from that. So it's going to be -4 to infinity, but not including -4, so parentheses. And behavior as x approaches negative infinity, or as x approaches infinity, f of x approaches. The left side is going to be right here. It's going almost flat to 1, so it's actually approaching 1. On the other side is going up and right, so f of x is going infinity on the right side. For this one, as x approaches negative infinity means looking at the left. That part is going left and up, so it's going up forever to infinity. And as x approaches infinity, f of x approaches. So over here, -4. X-intercept on the first one does not exist. The y-intercept on the first one, remember, x-intercept and y-intercept are points, so it's 0, 2. Second one, x-intercept does exist. It is at -2, 0, and the y-intercept is at 0, -3. These are all the things we have learned in the previous unit. Now let's move on. In the last lesson, we have defined exponential function as a times b to the x power. After some practice, you may have realized that we could actually add even more to this basic form. So today we're already going to expand it with the last part. We also add this last part, which is a plus c. The rest of the requirements are still the same. B is greater than 0 and b cannot equal to 1. And each part actually has a name. A is called initial value, B is called growth or decay factor, because B is affecting how fast the shape is growing, is changing, growing or decaying. In other words, increasing or decreasing. The C is called a vertical shift. So in previous practice, you might have noticed your graph's horizontal line that is approaching, that is actually affected by this last number. Growth, the graph is increasing from left to right, and decay is when the graph is decreasing from left to right. So these are the two extra things we're going to add into today's lesson. Then we have asymptote, a line that approximates the shape of a graph. A graph will continually approach but never meet or cross the asymptote. So that, as we have been talking about this exponential graph, when it's going flat on one end, is actually approaching this certain line, but it never crosses it. And that line is called the asymptote. And it's typically in exponential graph, it's a horizontal line. For an exponential function graph, the asymptote is a horizontal line in the form of y equals c. Now you may notice c. We have a times b to the x power plus c. So this vertical shift is the asymptote. So the horizontal line is actually at the vertical shift. We usually draw a dotted line as the asymptote. Well, because the graph is not crossing or touching it, so it's not getting there. It's just like when you were drawing system inequalities, when you're graphing inequality lines, we always use a dotted line if we can't get to it, or if it's not included. So there you go. Let's have a look at some examples. Example 1. The first few features are quite easy for you to go through. Domain is -infinity, +infinity. Range, well, this one, we actually have everything below until we go up to right there on the x-axis. We're not getting exactly that line, so it's going to be from -infinity to 0, but not including 0. As x approaches -infinity, left hand is going almost flat to 0, so f of x approaches 0. As x approaches infinity, f of x approaches on the right side is going down and right, so it's actually approaching -infinity. X-intercept doesn't exist because that part is not crossing the x-axis, it's going almost flat. Y-intercept is at 0, -4. Growth or decay, when you look at the graph from left to right, you can see it's actually going down. So it's going to be decay because the graph from left to right is actually decreasing. As for the asymptote, we are going to draw that on the graph. It's right here. This is the line it's approaching but not crossing. It's a horizontal line, so it's going to be y equals, and it's actually crossing the y-axis at 0, so it's y equals 0. There you go. That's example 1. Example 2 and 3, I'm going to ask you to pause here and try these by yourself. Now that you have tried them, let's have a look. Domain, -infinity, +infinity for both. As for range, nothing below until you hit right there at -1. So it's -1, comma infinity, both sides are parentheses. Range for the other one is, well, you have everything below until you hit right here at 3. So it's -infinity, comma 3, but both sides are parentheses. And behavior as x approaches -infinity. So this is actually approaching -1. On the other side, as x approaches infinity, f of x approaches is going up, right? So it's approaching infinity. For the bottom graph, as x approaches -infinity, well, this side is going down and left. So f of x approaches -infinity. As x approaches infinity on the right, is not going across this line at 3, so f of x is approaching 3. X-intercept, 0, 0. Y-intercept is also 0, 0. And on the second graph, x-intercept is, well, we can actually do an approximation. It probably looks like a -1.5, comma 0. It's an estimation. Y-intercept is at 0, 2. Growth and decay, the first one, well, going to the right is actually going up, right? So it's growth. And the second graph is also growing, it's just actually growing slower, but it's still growing. Asymptote, let's draw them on the graph. First one is exactly right here. The line is y equals -1. In case you haven't noticed, you see range, -1. That's also appearing in the end behavior. That's also appearing as your asymptote. Same thing here. Range that appeared in the end behavior. That's also going to be your asymptote. Y equals 3. Let's draw the dotted line on the graph. There you go. That is example 3. And that's everything for this first lesson of features of exponential function graphs. Thank you.